So we're going to pick up at the end of our last video, and what you may not have noticed is, so 33.75 or 34% of students are from a major city. But, you know, if I had 30% and 40%, we might have been expecting the answer to be 35%. And why wasn't it? Well, you've seen it, like mathematically why that didn't work, but generally you cannot average percentages. And it actually goes back to the fact that you can't add unlike terms. Okay, we've talked about it, but a percent isn't just a percent. It's a percent of, or a percent less, or a percent more than. So it's always this referenced value. So if they're percents of the same reference value, now they're like, but generally they're not. And so that's going to remind you, hopefully that reminds you like not to do weird things with percentages. Other fun is, if a store's having a 25% off sale, how do you figure out what you're paying? So what I want you to remember is that this 100% is like a whole something, right? That's the joy of percentages. It can be a whole anything. If you're saving 25%, what does that mean you're actually paying? Well, 100% minus 75 or minus 25% is 75%. So in this one question, you can actually talk about this two ways. So your sale price is 25% less than the original, and it's 75% of the original. So I want you to start recognizing that these are not only related to each other. We can have those values for both. Now, you can't have less than and more than, really, but you're either going to have less than and of, or more than and of. And of is nice because we know of is times. Less than and more than is nice, though, because they talk about the change. Here's a fun one that catches people. Let's say the cost of tuition falls by 14% one year and then rises by 14% the next year, or decade, or whatever you want. How its cost change? At first glance, we're like, it's fine. But what if we actually look at the numbers? So let's say tuition is $1,000 an hour. If we take off 14% of that $1,000, we end up subtracting $140, and we're left with $860. So that's what it would be after the fall. Well, what would it be after the increase? Well, we're going to take $860, and we're going to add 14% of the reference value, so 14% of 860. So this is actually 860 plus 14%, 0.14, times 860. Orders of operations say to multiply. First, multiplying those gives us $12.04, and not $12.04, $120.40. Close. And so when I go in to add those, well, I'm going to go ahead and multiply it. So 0.14 times 860, So this is $860, plus we've added $120.04, and you may already recognize that that's not $140 like we had. So when I add that to my original, this is $980.40. So what is the idea here? These have 14% have different reference values. So they're the same percent, but they're a different number, because one's 14% of 1,000 and one's 14% of 860. So this also, one more idea, this is 114% of 860, and it's 14% more than 860. Both of those using the same value, but talking about more than and less than. And we're actually going to do several of those in this section just so that we can kind of see how more than, less thans, and ofs relate to each other. I'm going to kind of fly through these, or try. Sometimes I get distracted. But what I want you to recognize is if it's more than, it's 100 plus that percent, but when it's less than, it's 100 less than that percent. Recognizing that I'm taking this and adding this to 100%, and so I can do that because I'm going to say this 100% is 100% of the same reference value. Another term I want you to get comfortable with is when we're talking about the percent more than or less than, we're talking about the percent change. There's one phrase I want you to be comfortable with, which is also called the relative change. So relative change, percent change, more than, and less than. All right, price of a movie ticket increases from $10 to $12. What does that mean about the new price? Well, the new price is what percent of the old price? So I can find this by taking the number, dividing it by the referenced value, multiplying it by 100, and get 120%. The old price is what percent more than, or the new price is what percent more than an old price. So if it's 120% of, that means that's 100 plus 20, so it's 20% more than the old price. You could also take the amount, the 2, and divide it by the tens. This is actually a big idea right here because it's the change divided by the reference, and that's how we find percent changes. What if I was multiplying? This means the new price is actually 1.2 times the old price. And you can see it works. 10 times 1.2 is 12. Let's say you bought an $80 shirt and you paid $48 for it. How much did you actually save? Well, we can subtract the 2 to see that we saved $32. This is something called the absolute change. I'm expressing the difference in the same units as what I started with. Just subtracting. Actual change. What percent is this then less than the 80%? So how much did I actually save? Well, I'm going to take the amount, the number, and I'm going to divide it by the reference value, the original value, which is 80. And that's going to give me 0.4, which I multiply by 100 to get 40. So this is actually was on sale for 40% off. I didn't pay 40% though, right? I didn't pay $32. I paid $48. So what percent is $48 of 80? And again, that percent of, I'm going to reference it back to the reference value, then I'm going to multiply it by 100, and I'm going to get 60. So if I saw something was on sale for 40% off, I could figure out what I'm paying by saying, well, I'm paying 60%, so I'm going to multiply 0.60 times it to know what percent of that I'm actually paying. So here, again, here they're added, right? 100 plus 20 is 120 because it's more than. Here they're subtracted. 100 minus 60 or 100 minus 40 is the other number because it's less than. Let's say you bought a new laptop, and of course it's not worth near as much as it was before. If it's now worth $300 and it was $1,000, that's $700 less. This is the absolute change. I just subtract the numbers. Relative change, what percentage less than 1,000 is that then? So I take how much it's changed by, divide it by 1,000, then I multiply by 100, and I get that this is 70% less. Remember, they're always related back to UBS though, so 300, the new value is actually what percentage of 1,000. You can divide and multiply to get 30, or recognize that the percent down is 70, so the percent left is 30. So, but this is what I want you not to lose. 70% less than 1,000 is not 0.70 times 1,000 because that requires of. It's 0.30 times 1,000 because that is where I can put of. 30% of 1,000. Let's say between 2000 and 2015, the number of twin births in a certain country increased by 14% to this number. How many twin births were there back in 2015? So I actually have the percent change, the more than value, but I need, if I want a really simple multiplication problem, I need this to be the percent of. So what I want to try to relate these to is 2015 births equals some kind of percent of the number of 2000 twin births. Okay, and what I have is it's increased by 14%. So if you want to look at the back at the top of your notes, or if you just want to think through it, if I had 100% and I increased it by 14%, now I would have 114% of. Why do we want of? This reason right here. If 2015 births is this number, 114% of changes to 1.14 times, and 2,000 is what I don't know. And now, while I do have a number I don't know, it's a number I know how to solve for. So remember, if you're multiplying by x, and you want to know x, we're going to divide, because this is going to leave me with 1x, which means I have my answer. This is going to be 116,000. I see a lot of people answer this problem with, I'm going to write it here in red because it's terrible, 150 something. Okay, just go right on. Answering it, pressing enter, not even thinking about it. Remember step 3 says to explain your results. If we've increased in births, could we have had 150,000 in 2000 and 132,000 now? No. Use your brain. You know that. But I just say it here with a smile on my face because I know sometimes we need that reminder.